So I gave, for those of you who were up in the French room yesterday, and I have it to understand that Madame Danielson taught a little bit of chemistry. Fills my heart with pride. But I'm going to go through and we're going to take a quick note on that topic that was sort of introduced in that homework yesterday, and then we're going to go on to one more topic with that. Okay, so if you're a little confused by the work I gave you yesterday, that's okay, because we're going to talk about it now. So I said yesterday, that's because I originally wrote this note when it was going to be the day after, but we could say
2 days ago.
Tuesday. We learned how many moles of a substance we had given its mass, right? So we learned that the reason we use that number, the mole, right? The reason we picked that really obscure random number, which is 6.02 times 10 to the 23rd of an atom, is because it just so happens when you have that many atoms, when you have 1 mole of atoms, how much does it weigh? What does it weigh? Very good. So if you have 1 mole of anything, you can just look at the periodic table, and whatever its mass number is, if you have a mole of those atoms, you'll have that many grams of that atom, which is obviously very convenient for measurement, right? So if we have a mole of carbon, all we have to do to get that mole of carbon is weigh out 12.011 grams of carbon, right? If I want a mole of oxygen, all I have to do is weigh out 15.994 grams of oxygen. Does that make sense? Okay. Now, that works great for elements on the periodic table, right? Because you just look and you say, okay, if it's one that I don't know, which is most of them, if I'm looking for tungsten, what's the chemical symbol for tungsten again? You'd think, right? No, it's the stupid one. They don't know? There's a few of them stupid, but this is the one I always forget.
T.
It's W. Makes sense, right? Must come from Latin. I'm not sure why. But anyway, so tungsten is W, and its formula mass, its atomic mass is 183.84. So if I want a mole of tungsten, I would get my scale out. It starts scooping on, and when I had 183.84 grams on there, I would know that I had a mole of it. Right? So I would know that I had 6.02 times 10 to the 23rd atoms. All right, so it's a convenient number because it's the conversion unit from atomic mass units, which are very, very small, and we can't weigh out, to grams, which are just very practical, right? We can just get a scale out, even a cheap scale, and weigh out 183 grams of something, right? The nice thing is here we have very expensive scales that can get us 2 decimal places of accuracy. It's very, very nice. You know, that's about a $500 scale. But you can buy a $20 kitchen scale and weigh things out by the gram, right? So we can be pretty accurate there. But what do we do when we're talking not about an atom, not about an element, but about a compound? How much does a mole of that weigh? So I want to look at the easiest example I can, which is water. So what is water? H2O. Good. Which means literally, if we look at it, oh. And there was light. So we have oxygen and 2 hydrogens, right? So every water molecule is made up of 2 hydrogens and 1 oxygen. So this is an oxygen molecule. Everyone remembers that word from grade 9 and grade 10. We haven't used it too much this year, but a molecule is what kind of compound? It's the smallest particle of a, well, we only know about two types of compounds. What type of compound is water? 50-50 chance, kids. Yeah. Yeah, good. Covalent compound. So when you hear the word molecule, you're talking about a particle, the smallest particle of a covalent compound. Right? So if it's got covalent bonds, it's a molecule. If it's got ionic bonds, it has the much less exciting name of formula unit. That's exciting, right? I'm not saying you should name your first son formula unit, but it's got a ring. It's got a ring. Formula unit Peltier. You could call him FU for short. Just an idea. I don't know why they let me teach. So we can use this information. We can use what we know about the water molecule to figure out what its molar mass is. And molar mass literally just means how much does 1 mole of a substance weigh. So if we think about it like this, molar mass or molecular weight or any of these things is always done with an uppercase M. And what is the molar mass of hydrogen? It should be 1.0079, I think. Is that true? Somebody have a periodic table in front of them? Yeah, we'll stop here. So different periodic tables give you different number of sig figs. If you want to put the 4 after, you go nuts, you. But I'm good there.
794.
Cool. And of course, we're saying that's how many grams are in. Very good. Are in a mole. You could write this as a fraction if you wanted to, right? 1.0079 grams on top, 1 mole on the bottom. But usually when we're just writing it as our given in a question, we'll write it like this just so it takes up less space. Does that make sense? Is everyone comfortable with the fact that that's kind of shorthand for putting 1.0079 grams on top and 1 mole on the bottom? Okay. What is the molar mass of oxygen? That should be 15.994. Is that true? 994. Oh, that's right. Oh, see, this is why we check our work. And that's also grams per mole, right? Now, let's look at water. When we go to figure out the molar mass of water, what's it going to be? Well, what is water made of? Yeah, so a 1 mole of water is going to have 2 moles of hydrogen, right? And what about oxygen? Just one. Just 1. Just like that, right? Does that make sense? And so when we go to find the molar mass of water, I'm going to have to do 2 times, what's the molar mass of hydrogen again? 1.0079 grams per mole. And we're going to add to that 15.9994 grams per mole for the oxygen. And obviously the answer is going to be roughly 18, but can somebody do that on the calculator to tell us precisely what it is? Yep.
I got 18.0152.
Great. And then let's just keep in mind that when we add and subtract, because remember here we're adding and subtracting, are we concerned about significant digits? No, when we add and subtract, we're worried about decimal places. Good. So how many decimal places here? 4. How many here? 1. So how many need to be in the answer? 4. And obviously we don't even have to worry about the multiplication, significant digits wise, because that too is accounting too, right? That's infinitely significant. So it's not going to change our significance. So this is 2 decimal places. This is also 2 decimal places. So our answer needs to be 2. Yeah, that's right. 4. Hello. She is, yeah. Sure. So that means 1 mole of water would weigh what? Yep. Very good. So if I take a scale out and I weigh out 18.0152 grams of water, and when I went to university, we had some balances that gave us 4 decimal places of accuracy. I'll tell you, they were misery to use, because if you breathe near them, they go crazy. Seriously, right? I mean, you think that little force. So they have like glass walls that seal them in, and you put your sample in. And they were these old German models. And they had this handle on the side that you go, and that released everything, and then you could weigh it out and balance it. It was all like You felt like you were in like a 1950s sci-fi movie. And you can weigh that out accurately. If I weighed out that much water, 18.0152 grams, how many water molecules would I have? Yeah. Which is? That's 6.02 times 10 to the 23rd water molecules. Does that make sense? Which means that I would have 6.02 times 10 to the 23rd oxygen atoms. And I'd have twice that many hydrogen atoms, right? Does that make sense? Which would be what? Roughly 1.208 times 10 to the 24. Hydrogen atoms. Okay. Does that make sense to everybody? Because we just get the molar masses from the periodic table, and we have a molecule that's made up of a few things, we just add together from the periodic table. The next one, I think I gave you carbon dioxide. Is that true? I want you guys to try that one on yourself. Please determine the molecular mass of carbon dioxide. And you're going to see different terms come up. Molar mass is the official term, but sometimes we use molecular mass. It means the exact same thing. Yeah, does anyone else want a calculator? I'll bring them around for you. Just shoot your hand up. There you go. You guys want to come? Okay. Anyone else? I wanted to mention, for assignments, I'd like you to use your yellow periodic table, which is quite accurate. For tests, just for simplicity's sake, I will give you a periodic table that actually has fewer decimal places, just to make your math a little quicker. For assignments, I want you to use this yellow one, which gives us more significant digits of accuracy. Ooh, getting to the gritty bottom of this thing. Yeah, wow.
So are all these like masses measuring numbers?
That's an interesting question. They're all measured numbers. Which means that we've actually weighed them out and done the math to get them. So I guess in theory they're never ending, but there probably are more significant digits than what you find on this. The truth is I've never bothered to look that up. I'm going to look it up tonight and let you know tomorrow. But because they're measured numbers, no matter how accurate they've been, they're still approximations. And that's worth mentioning, for example, because there's some of these things that we don't actually know. We do not know, for example, the mass of an electron. We have a rough approximation, but we do not have a good, accurate number for that. Does that make sense? Remember that we're measuring very, very, very small things. I don't know if that answer was useful, but they're not infinite in, say, the way pi is infinite, where they're calculated.
Sorry about it again. Is Jade Bar in class?
Yes.
Could Jade come to the office, please?
Yes.
Thank you.
It's such a shame to discover that everyone has discovered the Bar-Schaefer narcotics ring going on at Eastdale.
I didn't think you guys would find out.
Yeah, well, now everybody knows.
I knew it was you that told me.
It was me, that's true. Should have paid me off. Why am I saying this? I'm a sergeant. I'm so glad I record these lessons.
You're not recording.
Honestly.
You're not recording today.
I'm going to feel real guilty if she gets dragged out of here in handcuffs, by the way. Which I don't think is going to happen. But
If it does, you totally be following, don't worry about it. It's just going to be horrible.
Yeah.
So you're narcotics, right?
Because as soon as like you got paged and then Jade got paged, I was just like, oh, I can't believe they finally found out about the Sch34 narcotics ring, and then anyway. Hi, Miss Sargent. Okay, so how do I approach this question? What do I do? What do I do? What did you do, Pelche?
Molecular mass for carbon, and then use the previous molecular mass for oxygen.
Sure. So what? By the way, when we say molecular mass, that applies to molecules. So carbon isn't a molecule, so we'd have to say molar mass for that. Does that make sense? Not a big deal, but just worth mentioning. For carbon, it is what, 12.011 something?
12.0108.
0108, and that's grams per mole, of course. And what is the molar mass of oxygen? That is still 15.9994 grams per mole, right? You'll dream about these numbers by the end of this course. If you're wondering, like, how does he remember those? It's because, oh, they come up often. All right. And so what then are we going to do to calculate the molar mass of carbon dioxide? Yep.
Determine how many carbons and oxygens you need, and use that and multiply how much of what you need to make a compound by the masses.
Good. Yeah. So what would you do here? You would say
12.0108 grams per mole plus 2 times 16.9994.
great. And can I tell you guys what my habit is? As far as I know, there's no specific way to show this. I always put the molar masses in brackets. This is just my habit. This is not like thus saith the Lord. This is more like a thus saith Paul kind of situation. So the way I do it is I put the masses in brackets and then I put the number of them in front. Again, you will not get marks off if that's not how you do it. Just in my mind, that helps me keep track. So what number has to go in front of here? Dose. That's right. Man, I wish I spoke Spanish and I would have just kept going on this question in Spanish just to be difficult, but I don't. I do not. I barely.
Why are you talking about dose in this class? We already talked about it.
Oh, see what he did there? That was good. Okay, so what is, you get to hide, Orlando? And what do we get when we work this out? Oh.
44.0096.
44.0? 010 then 96? 2 zeros then 96. That makes more sense.
Grams per mole.
And that's grams per mole. Great. Please be sure you include the units, right? Units are very important. Otherwise, it could be 44.096 times I thought to myself how much I hate this class. I don't know, right? That 0.0096 is you started to think it and you're like, no, must resist the urge to be negative. Good. Well done. Yes?
We can show work every time for this then?
So here's what I want to say. To start, I want you to show all of your work. When we get a little more proficient at this, I will be happy to have you just show this. Does that make sense? I always want to see where these numbers come from. And then to be honest, in a few weeks' time, I'll be happy to have you just show me this. Just show me that you worked it out. Does that make sense? So I want to scaffold that. Every time I do a question, do I sit down and write out molar mass of carbon is this, molar mass of oxygen is that, molar mass of CO2 is no, I do not. I just start with my calculator in the periodic table, unless it's a tricky one, right? If I'm doing some big complex organic thing where I'm liable to screw up, then I'll write it out just so I don't make a mistake. Does that make sense? So for now, until I say otherwise, I want to see all your work, but I will actually mention as we move forward, hey guys, now we can start showing a little less of this. Is that a fair answer? What I don't want you to do is just get overconfident too quickly and make silly little casual mistakes. Okay? All right, let us look here. We just did 2 covalent compounds. This is an ionic compound. sodium bromide. Now, you'll note that with sodium bromide, what have I not given you? What have I not given you here? I've just given you the name of this thing, but I have not given you the formula. Well, that's okay. It's ionic, so can we figure the formula out? Of course. What charge does sodium take? Na takes charge +1. What charge does bromine take when it makes an ion? Yeah, beautiful. And so when they come together, what will the formula be? Yeah, just NaBr. Okay, now find its formula weight. The molar mass of sodium bromide. And this actually could be an example where we can try skipping one step. You know, we're getting good now. Maybe if you don't want to list sodium's molar mass on the side and bromine's molar mass on the side here, that'd be okay. But I want to see your work from here. The molar mass of what plus the molar mass of what, and any numbers you need to use. All right, so take a minute and figure this one out. So I just want to note, it's going to become common where I only give you a name and you have to figure out the formula. Once you figure out the formula, you have to figure out the molar mass, right? Like all those earlier skills, they don't go away. They just stick around. It's like basketball. It's not like once you learn to take a layup, you get to forget how to dribble. It's okay. That's great. Take it. Look at you. Look at you.
We got you did it wrong. No, I wrote it wrong.
Okay.
I'm sorry. Every time I see something doesn't correct, our instinct is not no, it's too bad.
How are we feeling? You got that? Great. Okay, so guys, what obviously this is going to be the molar mass of sodium plus the molar mass of bromine, right? What is the molar mass of sodium? 22? 9898. Comme ça? All right, and bromine? What is it? 79.904. Okay, and when we sum these, what do we get? Yes, ma'am. Okay, now Alondra ruined my fun. How did she ruin my fun? Yeah, she was too smart for me. Who earns? Because, again, when we're adding, are we concerned about significant digits? No, we're concerned about decimal places. How many decimal places did we have here? 4 decimal places. But here we had 3 decimals. And so, of course, the answer must only have 3 decimals. Good. And she put the unit on. Actually, I assume she did. I didn't actually. Did you? Okay, yeah, she's good. In time, she could be great. Questions about that? Okay, now we can go back and we can then do math with these. We can do math with these. So here we're going to do a question. We'll do one together, then one apart, where we have to do what we just did, but then use it to do some dimensional analysis. Does that make sense? Once we have that number, we're going to use it to do some thinking with it. So first of all, this question, how many moles of sodium hydroxide weigh 18.7 grams? Well, the first thing you note is what? Yeah, so we're gonna, our final answer is gonna be moles. Okay, that's good to know. What else? Yep. Cool. So this thing here, we're going to have to figure out its formula, right? Okay. So let's focus on that first. How do I figure out the formula of something? We've done this 1,000,000,007 times, but I write out what? So sodium takes what charge? Yeah, Na takes +1. And what the hey-ho heck is hydroxide? What do we got there? OH, and what charge does it take? -1. Good. So what will the formula of this thing be? NaOH. Very good. Well, what's hydroxide? It's made of oxygen and hydrogen. So the molar mass of this thing is just going to be the molar mass of sodium plus the molar mass of oxygen plus the molar mass of hydrogen. What's sodium again? 22.9494?
No. 9898.
9898. Sorry about that. And oxygen is 15.9994. And hydrogen is 1.00794. 795.
Grams per molar.
Oh, because I'm lazy. Here, let's fit that in. Ready? Ready? Yeah. Well, that one was really good. That one's even really clear. Look at that.
That's good.
Take a look. Like that's
awesome.
that's really good, right? Thank you for yelling at me about units. That's good. Yes.
How come it says on a yellow one for hydrogen 1.00795, but on the periodic table it says 1.00794?
So one of them is probably more up to date, and they've probably corrected it, or somebody somewhere at a publishing company doesn't know rounding rules. I mean, there could be lots of reasons, to be honest. The nice thing is that digit is not going to affect us in this case because we only have 4 digits anyway, and that is the 5th digit. And like the 5th Beatle, got fired. And we get this, we should get 40.0 what? 40.0. Oh, do you? Oh, I'm sorry, 39.9. 39.99.
So round up to 72.
Oh, so actually that last digit did matter. Look at that. Oh, fascinating. Yeah.
I did find out that one's more up to date. This one's out of date. It's 1.00794.
Whatever. for the purpose of this lesson, that digit is not going to kill us, but that is good to know. I respect that. Okay, so now we've found our molar mass, but that's not the question. The question was not what is the molar mass of sodium hydroxide. In fact, we have just set ourselves as ready to do the question, right? All we've done there is get a piece of information we need. The question actually asks me what? How many moles there are in what? Good. So we're looking for a number of moles. Now, as of right now, this isn't important, but just so we know going forward, when I'm finding number of moles, what letter am I going to use to represent that? Does anyone remember? Very good. So I'm going to use a lowercase n. Now, this is not important, right? Because we're not using the formulas. We're using dimensional analysis. So remembering those letters isn't going to matter to us, but you will see it. So I want to make sure I keep mentioning it. Does that make sense? You will see people use that. Now, how much sodium hydroxide did we start with? 18.7 grams. And of course, I'm going to say grams of. Very good. And what do I want as an answer? I don't want grams. I want moles. So I'm going to say moles of sodium hydroxide. And how am I going to cancel grams of sodium hydroxide? Grams has got to go on the bottom. And now, luckily, we've just found out how many grams are in a mole of sodium hydroxide, right? So I'm going to say, like that, and like that.
No.
What do you mean, no?
Wrong.
I'm the teacher, and I put it there. I think that makes it right.
Yeah, but you can say it out loud, Mr. Orlando. And
Maybe I don't want to say it out loud. Zach.
You can do it anyway.
Okay, so Kira, am I boring you? Oh, I'm sorry. I'm not sorry. These numbers don't work the way I put them because this tells me that there's 39.997 moles of sodium hydroxide in every 1 gram. That doesn't make sense. She is, yes. Yes. So are you being a character witness for Kendra Schaefer? Is that what this is?
Yeah, she was at my place doing video games.
Oh, an alibi. You're not just a character witness, you're an alibi. Isn't it odd that before you've even called down, you know the date and time we're going to ask you about and that she was at your place playing video games? It almost sounds like you're making this up. All right, yes. Everyone who's telling me I'm wrong, and Kira, who is finding me not funny and irritating for doing this, is right. This is not where the numbers go, and we always need to make sure we're careful about that, right? 1 mole is 39.9972? 71 if you changed your rounding. And again, keep in mind, depending on the question type, the numbers may be flipped, right? There's no way to know before you start a question if the one's going to be on the top or the one's going to be on the bottom. You've got to actually, you know, work it out. Now, what units cancel here? Yeah, because grams divided by grams is just 1, and 1 doesn't change the question. What unit remains? Yeah, so when we have finished this calculation, we will know how many moles of sodium hydroxide we have. And who would like to tell me what they get when they do this calculation? Yes, sir.
You get 0.4, 6, 7.
Okay, and what should I put here?
Moles of
But how many digits should I have on this? So 0.46. 8.
5 ounces.
Even number. Good. Keep in mind, this is 3. Now we're multiplying. So what am I worried about now? Decimal places or significant digits? Significant digits. Very good. So this is 3 sig figs. This is 1, 2, 3, 4, 5, 6 sig figs. Kira, this one's for you. Oh, I've got a problem. This one's only 1 sig fig. I better change my answer to 5, 0.5. Are you sure? Then why did I write 1? Respect my authority. I'm the teacher. It's 1 sig fig. All right. Fine. Fine. You know, if I teach you guys one thing, I'm hoping it'll be just to have complete disrespect for supposed intellectual authority. All right. And so our final answer to this.
Whoa. What's going on?
That was cool. I enjoyed that. I'll tell you, the Wi-Fi networks in this room today, they're a little haunted. It did not do that on my screen, I assure you. That's right. There we go. Yeah. What did you get?
We were getting the math about 39.9971.
Yep. So you'll get a mildly different answer in the final, but it should still come out to the same number of moles.
I got 39.99714.
Yep. Luckily, that 6th significant digit is not going to affect a number that is only 3 sig figs. You will get the exact same answer.
Oh, so the second exact same.
Yeah. Well, I'd like you to calculate it. Good practice. Wait, trust me. I've been intentionally writing wrong things on the board all day and probably unintentionally wrote a bunch too. And now you're just going to trust me? Oh, I'll just put what he put. Really? That's the takeaway from this lesson? Just blindly write what Orlando writes?
Like the hydrogen
Never right what Orlando writes.
All right, so I want you guys to try the next one. I want you to try the next one. It's the same basic question. This one, of course, instead of giving you a mass, gives you moles, and it wants the. What's it want? What unit will your final answer be? Very good. Your final answer will be in the unit of grams. By the way, when I do a complicated question, these are not very complicated yet, but every time I do a complicated question, I always write, before I do any math, what unit my final answer should be. Because so often we'll do a tricky part and then be like, hey, I did it, I got an answer, and then just stop, only it's not the end of the question. Does that make sense? Anyway, your final answer should be in grams. Yes, I would love to. What'd you get? Ooh, but here's the deal. Careful. That's wrong. And there's no unit. And there's no unit.
You're just a broken calculator.
There you go. At the end. Ah, because this isn't ionic. But that's okay. You know the formula. This is in the name. Carbon. Tetra. That's the yeah, this is a molecular compound, guys. When you figure the formula out, you got to look at those prefixes.
I know. My mom is in vision with it.
Do you not have the yellow one?
It's fine.
Whoa.
No, while you're, I just rummaged through your binder to find it and stole it.
Oh, put units. Put units. Otherwise, the unit police will come and give you 0. We'll drive away in the unit police cruiser. For the unit donut shop. And there'll be many donuts.
Unit donut.
I did donuts.
You make that scientific unit donut.
And then the school's giving them unit.
It's just on fire today.
Watching somebody like all the way in China or something, it's trying to see what it's like in North America, and it's listening to your lesson. It's what's the main why.
I didn't catch the first half of the comment.
Because somebody all the way in China is here to see what teaching is like in North America and is watching the license.
Really, they're just researching what future unemployment looks like.
Thanks.
I meant me. I didn't mean you. I meant me. How about myself? I think you'll all get a very good job. And when you've got your very good job, I hope you'll think of Orlando. He was all right.
He was all right.
I should buy him a sandwich.
Yeah, okay. That's all you Americans.
Oh, it's really simple, Kira. When you get rich, I'd like to eat more. So I'd like you to buy me food. There's no subtext there. I like food and I'm cheap. So
I think someone up there is
yeah.
Okay, so for this
That's perfect.
one,
Good.
like I did like this.
Yep. Yeah, you're perfect.
Okay.
Yep, that's great. Good job. Did you just ha ha ha? Okay, well, sorry. So let's check the number. Okay, so I. Okay. No, you know what? You did miss something. It's simple. So just go up.
I forgot to put the decimal there.
The decimal's in the wrong place. That's all. That's all.
Now.
So decimal 0. There you go. There you go.
Okay.
So you were right. I was wrong. You're so smart. I am less smart. Kira's just following my lead. Can't cheat on me if I haven't done it yet.
Good point. Well, there was just like one second. Not one.
This doesn't work. There's two significant figures, but then you get 3 for the answer.
They got to round it to.
Yeah, you got.
Okay, so what is the formula for carbon tetrafluoride? CF4. Very good. So now that's going to be the molar mass of carbon, obviously, plus what? It's going to be the molar mass of carbon plus 4 times the molar mass of fluorine. Very good. So when we do that, we get what? 12 point, what is this? 12.010. Okay. And 4 times, what's fluorine?
18.9984.
Okay.
Grams per mole.
Oh, good. Thank you. Keep me accountable. All right. And when we do that, what do we get? Kayla, what's my final molar mass here?
88.004. Oh, you looked at that. You didn't say that, wasn't it?
Yeah.
I only got 4.
I got 6. Why do I keep getting different numbers?
I don't know.
4, 6.
I don't tell you, Alondra. Okay, so now I'm done the question. I can be thankful and move on. Yeah, I haven't really started the question, have I? I've just gotten the information I need. The actual question wants to know how many mole, what the mass I'm given is, right? Okay, so what information do I start with here? First of all, yeah, I'm going to be looking for a mass. So I'm going to use a lowercase m because lowercase m means mass. Again, that's not super important because we don't use formula, we don't memorize formulas, and we don't draw little silly pyramids like this because we use dimensional analysis. We think our way through the process, and even if it's trickier at first, it'll be rewarding in the long run. It'll help us in the long run. So what information am I given here? Because that's always what I start with.
Oh, 3.2.
Yep. Very good. So I start with 3.2 moles of CF4. But I do not want to know how many moles I have. I want to know the mass. What should I do?
You multiply that by 82.0044 grams of carbon tetrafluoride and divide it out by 1.
Great. Very good. Very good. And listen, I know that it gets to feeling kind of pedantic to write those units constantly. I do insist on it. I really do. And it's one of those things, you'll thank me later. Just trust me. You'll thank me later. So we're going to write the full units every time. Or you won't thank me later. But regardless, we're going to write the units every time. What units cancel? Yeah. Moles divided by moles, that cancels. And that leaves us with what? When we multiply this out, we get grams. Great. And what's the number we get? Wow. Okay, so what's the problem here? I have 2 significant digits, or dose if you prefer. So 2 significant figures, and of course here we have 2, 4, 6, and here I have infinite. Okay, so how many significant digits does my answer have to have? 2. So you can do this one of 2 ways. What are the 2 ways we can write this? Yeah, we could write it as what? Alondra? Very good. We can write as 2.8 times 10 to the 2. Oh, but what's that unit? Grams? Grams of carbon. Yeah, she said it. I just didn't like what she said. You said grams per mole, but it's not nice. I think it's unnice. Unnice. Unnice isn't a word. I think it was unkind of you to use the wrong unit. That's what I think. Yeah, it would also have been okay, though I like the scientific notation better, to say what? We could have also said 280 grams of CF4, because we know that that last zero isn't considered significant. But to me, it's still kind of ambiguous. I don't love that as a... My preference in this case is for the scientific notation, though both would get you full marks. Both would be considered fair and good answers, but I do prefer the scientific notation. All right. Now, from this, I'm going to introduce you the lab that we were going to do on Friday. Well, we were going to do on Thursday, then we were going to do on Friday, then we're going to do next week. It's going to be next week. That's okay. Lesson will be online. The next lab we're going to do. The next lab we're going to do involves taking a compound in the lab and figuring out its chemical formula. All right, taking something that you don't know what it is, and we're going to figure out its chemical formula using masses. Does that make sense? So instead of going from the formula to the molar mass, we're actually going to work the other way around, which is challenging, which is tricky. So with that in mind, oh, you guys have the last page, do you not? If you go to the next page. Yeah, isn't it interesting that I do not? That's okay. We'll fill in this space, and I will come back after and print it in properly. But I want to talk about something today called percent composition. All right, so this is sort of the title of your page. And there's a little percent composition equals down below, right? All we're asking when we do this is, what percentage of the overall mass does one element make up? So before we even do any math, take water. Water is 2 hydrogens and 1 oxygen. So there's twice as much hydrogen as oxygen. But by mass, what's the heaviest part of water? The hydrogen or the oxygen? The oxygen, because those hydrogens are pretty light. Does that make sense? So a high part of oxygen's mass, a high percentage of its mass comes from oxygen, a low percentage comes from hydrogen. Does that make sense? If you broke water apart, which we'll do in a couple of weeks now, if we break water up into its parts, you're going to get more hydrogen atoms than oxygen atoms, but the oxygen you get is going to weigh a lot more. Does that make sense? Okay. So percent composition just means the mass of one element. That's a 1.
I was going to say that I don't think there's no such thing.
The mass of one element divided by the mass of the whole compound. And then, of course, to make it a percent, we have to... How do you make something a percent? Very good. Multiply by 100. Yeah, percent means out of 100. So, wow, my grandfather used to always say that. Then he'd throw things at me. You can see where I developed my sterling personality. I mean, light things at first, but... Okay, so let's look at the example I give you here. And I think that you'll take to this quite quickly. This is pretty simple stuff. So if we took a sample of sodium fluoride, and I want you to pretend that we don't know its formula. Now, obviously, how would we figure out the formula for sodium fluoride? Yeah, but we're not going to do that. Instead, we're going to say this. We took 3.65 grams of sodium fluoride, and we decomposed it. What's it mean to decompose it? Sorry? Yeah, we break it apart. And when we break it apart, we will get what? 2 things. Yeah, we'll get solid sodium, and we'll get fluorine gas. Does that make sense? So when we did that, we got 2.00 grams of sodium, and we got 1.65 grams of fluorine. What I want to know is, what percent does each of those make up of sodium fluorine? Sodium fluoride, rather, pardon me. So you're going to have to do two calculations. Doesn't matter which one you do first. Which one do we want to do first? Sure. So all we have to do is say the percent composition, and I'm just going to stop at comp because I'm lazy. Because I'm a lady. And ladies always use short forms. No. Listen. It's the 90s, kids. Ladies can write as many or as few letters of the word as they want. Don't let anyone tell you otherwise. When my mother was in high school, her parents sent her to a private school, and she refused to wear the kilt, so she got kicked out. So times have changed. Can you imagine?
Oh, yeah.
Imagine being like, I want to wear pants. You can't come to this school if you wear pants, Missy.
You are not acceptable.
Like, can you imagine? Yeah, different times. Thank God, different times. You have to wear a uniform, but you can choose. You can choose to wear the pants, right? Like, it's gotten a little better. Anyway, so how would I do this? If I want to know what percentage of this thing is made up of sodium, what am I going to put on top? Yeah, sodium, which is how much weight? 2.00 grams. And what will go on the bottom? 3.65 grams. Good. And in this case, the percent composition is what? Do that math. Well, how many decimal places how many significant digits do we want? 3 significant digits. So that's what I'd like. Yeah, what do you got? Very good, 54.8. I mean, I'm saying very good to the number of significant digits. I have no idea if the number is correct because I'm not a calculator. But
Really?
okay, so that's the percent composition of sodium. Can you do the percent composition of fluorine on the other side, please? Hey, Swiper, no forgetting to use significant digits. I never actually watched Dora the Explorer, so Hey, Swiper, no swiping is the only reference I know to the show. Again, I don't know what that means, but okay. Let's say yes. Everybody, the periodic table is now the map. Good. My kids liked Dora, but I didn't have a TV when they were little, so I only watched at their grandma's house.
Have you ever thought about how creepy it is if you don't respond to the door when you got to your questions, you just stare at that?
Yeah, that.
Listen, I got news for you. That's just teaching in a nutshell. Teaching is basically playing Dora the Explorer in an empty room. Do you know? Do people still watch Ferris Bueller's Day Off?
Yes.
Ferris Bueller's Day Off. You know the scene with Ben Stein as the teacher, and he's going like, and that led to the anybody rhymes with late repression. Yes, the Great Depression. That's right. That's how I feel teaching every day. Anyway, get to work. Oh, it's so good.
I love it. I want something.
I'm always interested to know because these movies have like a nostalgic appeal to me too. So you wonder, like, are they actually good? Like, is somebody seeing it who didn't like when it wasn't a pop cultural thing? Like, is it still a good movie? So I'm glad to hear it holds up. Okay, what am I putting in here to make this work? 1.65, and on the bottom, 3.65. All right. And when we do that, what do we get? 45.2. And of course, these two Percent compositions must sum to.
100.
You guys don't have to write that whole sentence. I think I gave you it with a space, right? And I think I put stars next to it. That's to tell you it's important. But since I'm here, I'm going to put. That's right. That's right. Spanish exclamation marks. And a hashtag. There we go. All right. Try and stop me. Try and stop me. Sorry?
100% factorial.
That's right.
Do you actually know why they have it like that? They have like one of the exclamation marks upside down.
I don't, but I like it.
Yeah, actually.
Oh, is it?
They do that because they believe that you have to have the entire sentence be that way,
Not just the last word. Yeah, I like it. Well, and it also, for the record, that would be really helpful if you're like, I can't tell you how many times I read out loud to my kids, which I'm sure at this point they hate, but I still enjoy it. So I think they listen just to pity me. But so often you'll be like reading, and then you get to the end and you see the punctuation, you're like, well, I read that whole sentence wrong. It also happens if you use voices where you get to the end and you realize you've been in the wrong character, and you're like, now I've got to backtrack. Anyway.
Oh, I've read an entire book.
Okay. I want you to do example 8. And example 8 is tricky because have I given you any masses whatsoever?
No.
No, that's okay. Here's what I want you to assume. Assume you have 1 mole of water. Because if you have 1 mole of water, then you know the masses of everything involved, right? In fact, you don't even have to figure them out. You can go back to, we did example, what was that? Example 1, I think, the first example in the entire note. Yeah. Has all the masses you need in it. Does that make sense? Okay. So that's going to be your task for the rest of class. And for homework, we'll take that up tomorrow. But I want the percent composition of water. What are the 2 things that are in it, obviously? Yeah. So you're going to have the percent composition of hydrogen. And you're going to have the percent composition of oxygen. All right. So that's your task. Yes, ma'am.
I never know how to round.
No problem. So which digit are you rounding to?
The second one.
So that one. Okay, so that's going to round to a 0. And that 0 is going to make this what? Like this is really rounding to 10, right?
Yeah.
So that 0 is going to make this 0, which is going to make this 9. So when you round a noun,
when you round a
noun, 9 cascades. If it has to become a 0, the next number becomes 1 higher, right?
Okay.
And if that has to become 0, then the next number is going to become 1 higher. Does that make sense? So it's the only one that does that. But when you round a 9, you have to keep going left until you get to a number that isn't a 9. And that's the last one that goes up. Does that make sense?
Okay.
Yeah, very good.